Okay, hey guys. Today we're doing the Fermentation Prac. That's the one in class. I think it's the second one in class we did. It was the one where we had to ferment glucose using yeast, and we wanted to measure the mass change and what gas it produced. Alright, so we'll just hop right in. Now, before we go right into the actual prac, I want to really just know what fermentation is first. That'll help us a bit. So we can write down the reaction if we want for fermentation. That'll be good. And we'll balance it as well. So it's glucose, CH12O6, that's glucose. And it goes through yeast, or any microbe really, but we use yeast in class, that's what we'll do here. Glucose, and it goes into ethanol, C2H5OH plus, now in class we worked out it was CO2, so we're just going to write it now so we have a firm grasp of it before we get into the prac. And we want to balance that, so to balance it all we really do is add a 2 here and a 2 there. Okay, so now what technically is fermentation? Well, it's the breakdown of glucose through microbes and single-celled organisms like yeast to form simpler molecules such as ethanol and carbon dioxide. Now, two important things to remember about fermentation. First off, it is exothermic, okay, which means it produces heat. Okay, it produces heat or produces energy, for example. It produces heat. We all know what that means. It releases it. So if you put it in water, and it happens, the water will heat up. It is also anaerobic. I'm not sure if that's spelt right, but this just basically means that this reaction, not only it doesn't occur in the presence of oxygen, so there's no O2 in here, but it's not only that it doesn't, but that it can't happen with O2. So for this reaction to take place, there cannot be oxygen present, which is why they do it. They do this in barrels and things like that. It has to be a very low oxygen environment. There can be some, but the less there is, the more effective this will be. Yeah, so that's basically all the science or the chemistry behind the fermentation process. It's pretty simple. It's a lot simpler than the bromine water science, the bromine water theory. But the actual experiment turns out to be a little bit trickier. Okay, so our equipment, we'll just go through this pretty quickly. We have a sidearm flask, a sidearm conical flask. We have a electronic balance, okay, I'm just going to write shorthand if that's okay. We have a measuring cylinder, measure silk. We have a bit of cotton wool. Now you can get like balls or some of that bundle. Just a good supply of cotton wool, okay, because we might do some tests. A small measuring teaspoon, so it's a small teaspoon. My writing is awful today, I'm sorry. Some rubber tubing. We use this in class whenever you use the side conical flask. We also want a test tube rack, of course, to hold our test tubes. That's not spelled right. Oh well. We also need a incubator. Now this part probably won't factor in the actual pracking class, but we still need to know all of it, what we did, because they might ask us questions. It might be based off theory. It might be based off the first half of the prac. In terms of our ingredients, we have yeast, which was 1 gram. I'm using just arbitrary values here. You can change these, but these just help out with the math. It's a bit simpler when we use these values. We have glucose powder, and that was I think 5 grams. We have distilled water in those bottles. Distilled H2O, and that was, I think, 100 milliliters. That sounds about right. And we had lime water. There's no real amount of lime water we need, just enough to, maybe fill up half of a test tube, or maybe 3/4 of a test tube. And just for your information, lime water is CaOH2, it's calcium hydroxide. So basically, the prac. What is the prac? I'm not going to write down the method for you. I'm just going to explain as I draw a diagram of the prac, a progressive diagram. Okay, so first off, we have our electronic balance. This is not going to be a very good diagram as well, by the way, guys. That's our electronic balance. It's stuff in the front, right? Now, what we want to do is we want to measure out 5 grams of glucose and add it to our sidearm conical flask. So, conical flask looks like this. Yep, this is great drawing, guys. Sidearm looks like this, has the little sidearm comes out, then it has the slightly elongated neck on the top. Okay, so we're going to get our small measuring teaspoon and measure out 5 grams of glucose powder. Now we'll be able to see the mass change on here. We don't have to zero it because we don't actually need the exact mass, we just need to see the mass change. So 5 grams of glucose powder, we can then add 1 gram of yeast. We use the same little teaspoon. And now using a measuring cylinder, I'm not going to draw that, you guys know what it is. Using a measuring cylinder, we add in 100 mils of water, distilled water that is, into it. So it should be around, not too much, but enough to basically dissolve all this. We then switch that around, so all the glucose powder dissolves. It'll look really cloudy because of all the yeast. It'll turn a little bit brown maybe, but just make sure there's no big lumps of powder in there. It's all relatively dissolved. Once we've made sure we've dissolved it all, we want to plug this top with cotton wool. Now the reason we use cotton wool and say not a cork or a stopper is because this reaction produces gas, as we know. And so if that pressure builds up enough, we could break the glass, we could break the incubator, and it could explode. So we want to put cotton wool just so if the pressure builds up, it can actually just release and be harmless. We're going to position this cotton wool as well so it doesn't actually block this entrance. I did that, and I blocked that entrance and skewed my results. So we want to make sure that that cotton wool does not block that entrance. Once we've got the cotton wool firmly in, you can try that a couple times, by the way. You can use multiple pieces just to see how much you need so it won't fall in. Just take your time with that, it's important. Once we've got the cotton wool in, we just need to attach the rubber tubing, okay, which is basically what will go into the test tube. So we have our rubber tubing on there now. Once we have this set up, so the cotton wool, the rubber tubing, 100 mils of water, 5 grams of glucose powder, 1 gram of yeast, we weigh that. Now we record this mass. We don't need to worry about the cotton wool and the tubing because we'll weigh that with the conical flask later. I'll explain that. Once we've done that, we place this rubber tube. Once we've weighed it, we place the rubber tube into our test tube. It's a great test tube, which is half filled with lime water or 3/4 filled with lime water. We want to position it so that this tube is underneath the lime water, and we'll place that test tube in a test tube rack. Once we have this set up, we place all of that into an incubator. So we're inside an incubator now, and this incubator should be set to around 36 degrees Celsius. It could be 35, it could be 35, it could be 37. Doesn't really matter. Give or take one degree, but just 36 is a good temperature for it. Once we have that set up, we left it for around 2 days, and we came back and we looked. Well, first off, we saw that this lime water had turned milky. It's because the CO2 produced, as we said before from the equation, goes up here, hits that cotton wool, and is forced through the tube, out through the water, the lime water, and into the atmosphere. Okay, that's the CO2, the carbon dioxide doing that. Now that loss of carbon dioxide there actually contributes to the weight loss we feel. So we prove it's carbon dioxide because it travels to the lime water. And then we say, okay, because it's been losing that, and we measure it, we'll see a slight change in mass, probably around 4 or 5 grams in mass. And that's explained through the production of CO2 and how that escapes through the atmosphere. It also smells a bit, and that's because of the a small amount of evaporating methanol and maybe some rotting yeast. So once we get those values, we want to add them into this table. Now this is how the table should be set out. We can make it a bit more complicated if you want, with quantity, say quantity 1 and quantity 2 after several days, so we can get a sort of graph going. But we only did one calculation, so we'll just use it now. Our initial amount of glucose, if we go back up to here, was how much? 5 grams. So we put that into the table. That is our initial mass of glucose, 5 grams. Our initial mass of the whole system, that is of everything here, that I'm not actually using real values right now, I'm just going to sub them in. They're relatively close to what we did in class. I'm just going to make them nice and whole so we don't get too big of a decimal place. So we'll just say 430 grams. Okay, and the final mass we'll say was 420, say 25 grams. Actually, you know what? Let's change this 5 grams. We'll change that into a 10 grams. Now this is just for the sake of calculations, okay? Use whatever you want and you'll get different results. But let's change this to 10 grams and change this to 5 grams. Okay, that'll make it a lot simpler. So once we've got all these in a table, we can then start working on the questions that they ask us. Now I'm going to do all the questions that they asked us in the booklet and that they could ask us with this experiment. Okay, so if we scroll down, we'll see then we can analyze our results basically. So the first question was, what was the number of moles of the reactant used? Now the reactant is what will react, so in this case it is the glucose,